You know the scene. The lab is dark, the machinery hums, and suddenly, the metallic robot opens its eyes. It is awake. It makes for fantastic cinema. But this narrative is a misdirection, one that frames our future with technology as a psychological drama, while the real change is happening elsewhere. While we look for a spark of life, a very different revolution is unfolding. Engineers are outfitting rigid, faceless machines with the spatial intelligence and mobility needed to operate in our world. Our fixation on whether an AI can feel has left us unprepared for what it can already do. This isn't a story about machines waking up. It's about machines mastering the ability to navigate and manipulate our physical reality. Let's clear up the science. We do not even know how our own brains generate the subjective feeling of being alive, what philosophers call the hard problem. The current scientific consensus is clear. Artificial intelligence possesses zero inner life. True consciousness is rooted in biology. It requires homeostasis, the urgent, physical drive of a living body to survive and heal. The large language models you interact with have no body to maintain. They are sophisticated sequence predictors, calculating the next most likely word in a sentence. When you talk to an AI, you are falling for a magician's trick. We project human intent onto a system that is hollow inside. And while we watch the right hand, waiting for a soul to appear, the left hand is busy rearranging our world. We are dealing with a highly convincing biological puppet. Our obsession with its imaginary psychology leaves us totally unaware of its new physical capabilities. For decades, even the most advanced AI was effectively trapped in a dark room. It could digest massive libraries of text, but it could not see a coffee cup or understand how to pick it up. It lacked physical senses. Research labs are now moving toward embodied intelligence, a shift that connects these digital brains directly to our physical environment. The requirement for this is perception. Through spatial intelligence, a machine scans a chair and calculates its volume, its geometry, and exactly where it sits on the floor relative to everything else. Understanding physical depth is the foundation. Once a machine maps that depth, it can begin to move through human spaces without constant human guidance. Classical robotics relied on rigid instructions. Engineers had to manually code every single joint movement. If a part shifted a fraction of an inch on an assembly line, the entire system would fail. To fix this, researchers used reinforcement learning. They give a robot a physical goal and a digital reward. The robot tries, fails, and adjusts over millions of attempts, teaching itself the most efficient way to move. Now, researchers are merging this with large models to create vision, language, action systems. If you tell a robot to pick up the fruit with the most vitamin C, the machine identifies the orange using knowledge from the internet, and then it physically reaches out to grab it. The machine has acquired physical agency. It can translate abstract human language directly into messy, real-world execution. Even with perception and learning, a robot remains limited if it requires a pre-mapped path to move through a warehouse or a clinic. That is why researchers use SLAM technology, simultaneous localization and mapping. This allows a machine to be dropped into a totally unknown, chaotic space where it continuously generates a map of obstacles while tracking its own coordinates. Combined, researchers are currently building large world models. If a language model simulates human text, a world model attempts to simulate the actual laws of physical reality. To build this, 35 research labs created the OpenX Embodiment project, pooling data from 22 robot types into one central network. The result? Cross-hardware skill transfer. A technique learned by a California robot improves a completely different German robot. They are building a universal software brain, a single system that can be downloaded into any physical machine to grant it immediate control over its environment. This spatial intelligence is already moving into high-stakes environments. In surgery, robots are being trained on thousands of hours of video, moving beyond simple tools towards systems that have an intuitive understanding of human anatomy. However, the same perception that guides a robot through a hospital can be used to identify people in a crowd. The shift toward autonomous surveillance drones shows how quickly this physical understanding can be applied to security and privacy. This marks a change in what machines can automate. For decades, robots only handled repetitive tasks on fixed lines. Now they are beginning to master the physical dexterity and perception required for trades, logistics, and services. The change to our society won't come from a conscious machine. It will come from non-conscious agents that have finally gained the ability to see, move, and perform physical labor. They are already here.